In this video, we are going to take a look at what a hyperbola is. A hyperbola is the last of our four conic sections. So, technical definition, and then I'll go through the picture. A hyperbola is just a set of points in a plane. The difference of whose distances from two fixed points those are its foci, is constant. So here's a picture of a hyperbola. The hyperbola is this blue part here. This is the hyperbola. And then the foci on this, in this specific example, is this dot here and this dot here. So what they're doing is they're connecting these two foci, and when I subtract those lengths, it always is the same distance. So it's always the difference. Excuse me. And what ends up being formed are these asymptotes. So that's one of the big differences between a hyperbola and a parabola. A parabola keeps going on forever in both directions. As x approaches infinity, y will approach infinity, or if it's approaching negative infinity. But in this case, we're going to be looking at, it's going to be bounded within these regions, these asymptotes, which we're going to look at and find. So here's all of our information. We're going to have two different types of hyperbolas. We are going to have a hyperbola that opens left and right. And then we also have the hyperbolas that open up and down. And in the opening of our hyperbola is a focus. Two of them is foci. There is the vertex as well for each of our hyperbolas. And then we have those asymptotes, which we're going to find based on drawing these boxes. We have the conjugate axis and we have the transverse axis. The conjugate axis is the one that does not run through our vertices. The transverse one is the one that cuts it in half. If you want to think about transverse, it cuts something. So this one cuts your half of your hyperbola in half. Okay, so just some vocabulary terms when we start looking at things. You can think about the transverse axis as our major axis. And that contains the foci. And then we have our conjugate axis, which think of as our minor axis. So the major axis contains our foci, it contains our vertices. It's going to be that principal piece to it. When you start figuring out what your equations are going to be, you're going to determine which direction these are opening. So in the left case here, our major axis is our horizontal axis. So when our major axis is our horizontal axis, it's going to open left and right. Versus when our major axis is our vertical axis, that's when it's going to open up and down. And we have two different equations for these. So when our hyperbola is opening left and right, it's because our major axis is our x-axis. The equation for that is x squared over a squared minus y squared over b squared equals 1. Very, very similar to ellipses. Okay, again, because our major axis is running horizontally, my x squared value is first. Okay, and this is going to change a little bit from ellipses. Versus, when it's opening up and down, my major axis is my vertical axis. Since my major axis is my vertical axis, this equation is y squared over a squared minus x squared over b squared equals 1. This one's going to start with our y squared. A is always going to be on the bottom. of your first one. So if it's horizontal, a squared's under your x value. If it's vertical, a squared's under your y value. And again, I know this is going to open up and down because I start with y squared. And we have to change this because of this subtraction sign, because it's going to be the difference. Each of these have asymptotes, and asymptotes are going to bound our points. So once I find my vertex, then all I need to do is find my asymptotes, and then I'll be able to draw my picture in. So my asymptotes on the horizontal opening is y squared equals positive and negative b over a times x. So it's your b value over your a value. So looking here, here's my b values, here's my a values. I'll show you a picture of this so you don't have to just memorize this. And then our vertices are at plus and minus a, 0. Now this is dealing with non-translated hyperbolas, and we're just looking at them having that initial center value at 0, 0. On the opening up and down, where my transverse axis is my vertical axis, I have asymptotes here at y equals plus and minus a over bx. And then my vertices are at 0 plus and minus a. We will be able to also find our foci, just like you did with the ellipses. When we're finding our foci, works the same way for both of them. Remember, it's on your major axis, your transverse axis. C is the number of units from your center. So you're going to have to figure out where your center is. Right now, we're just doing centers at 0, 0. And to find C, it's c squared equals a squared plus b squared. Again, a little bit different formulas than what you worked with ellipses, but it looks similar, so be really careful that you don't make that mistake. So we're going to start by looking at an example, and we'll talk about what the a values mean, what the b value means, and how this works graphically as well. So in this example, we're going to identify the vertices, the foci, and then we also have to write the equations for our asymptotes. Step number 1, determine which way this is opening. Is my major axis horizontal or is my major axis vertical? Since I'm starting with an x squared, this is going to be a horizontal. So I know I'm going to have my transverse axis right here. That's where my transverse axis is going to be, which means my center's on that spot, my vertices are on that spot, that equation, and then also my foci lie there. So that's going to be a really important axis for us to have. Now, because of our equation, I know my a value. Remember, it's over a squared. We're used to that. So that's 9. And my b value, it's over b squared, which is 5. Based on that, I can figure out where my vertices are. Now, this a value is how far the vertex is from the center. So my center right now is at 0, 0. My vertex is 9 units over. So from my center, my vertex is 9 units to the right and 9 units to the left. Again, this is because that's the direction our major axis is on. It's physically on that. Distance away is 9. Now the 5 is going to help us figure out where my asymptotes fall. So to begin with, I've done my vertices. Vertices are based on your a value. So one vertex is at 9, 0. The other vertex is at negative 9, 0. Now to come up with my asymptotes, I'm going to have to also use my b value. Because what this ends up doing is it creates a rectangle for me. So the b is how far I'm going to go on my minor axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what this ends up doing is it creates this box. Here, here, off a smidge, here, and there. So now, Within this region is where my asymptotes fall. This is the easiest way to draw your graph is once you can get your asymptotes in. So this is my boundary piece. So if you remember, I said to find your asymptotes, it's plus and minus b over a, because it's the slope of that. Realistically, if I connect corner to corner, and I'll have to extend that out a bit, and corner to corner, I now have my asymptotes written. So to figure out what this is, I have to do my rise over my run. So from my center up is 5, and to the right is 9. Therefore, my asymptote, remember it's rise over run, so it's y equals 5 over 9 times x, because it's an oblique line. That's the equation for it. And then it's also 5 up and 9 to the left, which is why it's plus and minus. So either you can memorize that it's your b value over your a value plus and minus, or if you draw that box in, you'll be able to just count up. Count from your center up and over, whichever direction it is. But the reason I actually drew these asymptotes on is it helps me draw my graph. Once I've done this, I can now graph it. So from my center, I go up towards my asymptote without crossing it. Up towards my asymptote without crossing. Same thing on this side. Makes it a lot easier than having to plug in points to figure out where the rest of the curve goes. The last thing I need to find is my foci. So I'm going to have to be able to figure out approximately where my foci falls on the graph. So to find my foci, it's based on this formula, c squared equals a squared plus b squared. So c squared equals a squared was 81 plus b squared, which is 25. So therefore, c squared equals 106, which means c is the square root of 106. So that's the distance. The c value, remember, is the distance the foci is from the center, which is why it's only a positive. Typically, it'd be plus and minus. However, distances is always positive. So I have to go the square root of 106 over, which you might not know exactly where that is. So at this point, you're going to grab your calculator, and you get approximately 10.29. So it's just going to be off my graph a smidge. So there's one foci, and there's the other foci. So from my foci, my coordinate point is the square root of 106 over 0, and negative square root of 106 over 0. Again, those approximations as well. So that's how you can figure out all of the different key features based on your equation. Now, one more. If you remember, your hyperbola's equation is x squared over a squared minus y squared over b squared equals 1, or the x squareds and y squareds could switch. I'm telling you that this is a hyperbola, but one of the things that you're going to have to notice is how do I get used to seeing this? This is very similar again to ellipses. I have to divide both sides by 100 because it has to equal 1. So before you even get too far into this, you end up having to divide everything by 100, which gives me y squared over 4 minus x squared over 25 equals 1. So now you have that hyperbola formula. There's that subtraction sign in the middle, which is why it's a hyperbola. So what I'm going to have you do is I'm going to have you pause it right now and see if you can go through this without listening to me go through it. And then after that, I'll walk you through everything if you do get stuck along the way. So pause it now and try this problem. Okay, so first things first, you should see that this is vertical. That's where our principal axis, our major axis, is going to be, because our y squared is first. Because it's y squared minus. I'm subtracting the x value, which is why I have that principal axis going vertically. Then from there, needing to figure out my a value, my b value. I know my a is 2. I know my b is 25. So from my center out to my vertex, so my center is at 0, 0. It's not shifted anywhere, so here's my center. So from my center to my vertex, my distance away is 2. So from here I go up 2 and I go down 2. Therefore my vertices are the coordinate points 0, 2 and 0, negative 2. And then I'm also going to take my b values and go horizontally 5, because this is going to help me find that box. So now I know my asymptotes are going to fall through their diagonals, which then tells me my asymptotes. My asymptote is an equation, y equals, it's still your rise over your run, so it's still the change in y, so from my center up 2 and over 5. It's positive and negative because it also goes up 2 and left 5. X, because it's a line, it's an oblique line. With my asymptotes drawn on here, now I can draw the shape of my graph, but you got to remember which way it goes. It goes vertically. So it's going from my vertex, and it's curving up to my asymptotes, down, following my asymptote behavior. So be careful, make sure you have it going the right direction. Since my y squared is first, it's opening up and down. And now I just have to find my c value so I can find my foci, which is, again, that distance away from my vertex is where my foci lands. The distance away, from my center. So therefore, c squared equals a squared plus b squared. So c squared equals a was 4, a squared was 4, and b squared was 25. So c, therefore, is the square root of 29. So my foci is the square root of 29 away from my center value, which is about 5.4. So from my center, so there's one focus, and there's my other focus. So for my foci, because it's centered at 0, 0, it's 0 and the square root of 29, and 0 over a negative square root of 29. So you're going to practice graphing and finding these key pieces of information for hyperbolas that have not been translated.